Good evening, students. How are you all? Welcome to the new series where we'll be discussing arithmetic progression. So please observe the list of numbers which I'm writing here on the board. 2, 5, 8, 11, 14, 17. Now please observe this. Can you tell me the next number after this? We have 2, 5, 8, 11, 14, 17. So the next number would be 20. Very good. So the next one, it would be 23. Very good, very good, very well observed. Now, could you observe a pattern here? Yes, you're right. Every time we are adding 3. So we started from 2 to go to 5. We are adding 3 here. Now 5 to 8, we are adding 3. So every time we are adding 3 to the previous number to get the next one. Here also we are adding 3. And here also we are adding 3. And in the same way, from 17 to 20, we are adding 3. From 20 to 23, we are adding 3. So every time we are adding 3. Now, please observe the next one. We have 8, 6, 4. The next one would be 2. Very good. After 2, 0. Then minus 2. So please observe this one. We started from 8 and every time we are subtracting 2 here. We are subtracting 2 to get the next number. Here also we are subtracting 2. The same thing we are doing here, and here also we are subtracting 2. Now either we can say here that we are subtracting 2, or can we say that we are adding minus 2? It means the same thing, right? So in the first list of numbers, we have 2, 5, 8, 11, 14 and so on, where we were adding 3 every time. In the next list of numbers, we have 8, 6, 4, 2, 0, minus 2. Here we can say either we are subtracting 2 here, or we can say we are adding minus 2 here. It means the same thing. Now please observe the next sequence here. 5, 5, 5, 5. So the next one would be 5 again, 5 and so on. So what are we doing here? It remains the same. It remains the same. We are repeating the number 5, 5, 5, 5 and so on. So we can either say here we are adding 0 or subtracting 0. It's the same thing. We are actually repeating the same number. So we can also say that every time we are adding 0 to get the next number. Here also we are adding 0. Here also we are adding 0. Now all these list of numbers here which I have written, they are arithmetic progression. Now what does this arithmetic progression means? An arithmetic progression is a list of numbers where each term we obtain by adding a fixed number to the preceding term except the first term. I'm repeating this. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Like in the first case, we are adding 3 every time. Please notice the number which we are adding every time to get the next number is 3. It is the same throughout. We are not varying it. We are not adding 4, 5, something different. Every time we are adding the same number. We started from 2. So in this case, we can start from any number randomly. But every time we have to add a fixed number to get the next one. Like in this case, we started from 2. We are adding 3, 3, 3, 3. Every time we are adding 3. It's the same throughout. So an arithmetic progression is a list of numbers where each term is obtained by adding a fixed number to the preceding term except the first term. The first term can be anything, and every other number we can obtain by adding a fixed number. So in this case, we were adding positive 3 throughout. Now coming to the next list of numbers, we have 8, 6, 4, 2 and so on. Here we are adding minus 2 every time to get the next number. So we started from 8 and we added minus 2 every time to get the next number. So here we are adding a fixed number, that's minus 2. And in the last one, we are adding 0 every time to get the next number. So we are adding 0 every time to get the next number. Now this fixed number which we have, like in the first case, the fixed number which we were adding was positive 3. And in this case, we have negative 2, then we have 0. So the fixed number is called the common difference. That's called common difference of the arithmetic progression, and it is usually denoted by small d. It is usually denoted by small d. So in the first case, the common difference is positive 3, and in this one the common difference is minus 2, and in the last one the common difference is 0. So the fixed number which we are adding to get the next term is called the common difference and is usually denoted by small t. The common difference can be positive, negative, or 0. As we just noticed here we have positive number, here we have negative, here we have 0. So common difference can be anything. It can be a positive number, a negative number, or 0. Now let us observe one more sequence here. We have let's say that we are starting from 5. Then the next one, let's take as 7, then 9, 11, 13. The next one would be 15. Very good. So every time here we are adding 2. Could you please observe this here? We are adding 2 every time. We are adding 2 every time to get the next number. So what is the common difference? So the common difference, the fixed number which we are adding every time, is positive 2. All right. So also here we have 5 as the first term. This is the first term of the sequence. So all these numbers, they're called terms of the arithmetic progression. So here this is the first term. The first term is usually denoted by small a. So here the first term is 5 and the common difference is positive 2. Now please observe this one. 7, 8, 11, 23, 50. Is it an arithmetic progression? No, it's not, because every time we are adding a different number. Like just see, we added 1 here. Here we are adding 3. Here we are adding 12. And here we are adding 27. So we are adding different numbers every time. So this is not an arithmetic progression. Now, make you observe one more sequence here. So here you observe this one. 1, 2, 3, 4, 5, 7, 8, 9. Now please notice this is not an arithmetic progression because we are adding 1 here, we are adding 1 here, 1 we are adding here, here also we are adding 1, but here we are adding 2. So we are not adding the same number throughout. We are adding, like in this case we have different. This is 2 here, so it should be the same throughout. So this is not an arithmetic progression. Okay, so let us quickly revise the definition of the same and then we'll proceed further. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So this fixed number is called the common difference of the AP. AP is the short form which we use for arithmetic progression. The common difference can be positive, negative, or 0. Also, students, please notice here an arithmetic progression can either be finite or infinite. That means it can either have finite terms, limited terms, or infinite terms, unlimited terms. That means the arithmetic progression can go on forever. Now let us discuss some questions which are based on NCERT. It's given on page number 99, exercise 5.1, question number 1. In which of the following situations does the list of numbers involved make an arithmetic progression and why? So the first one we have the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So is this an arithmetic progression? I'm repeating this. The taxi fare each kilometer when the fare is 15 rupees for the first kilometer and 8 rupees for each additional kilometer. So for the first kilometer, the taxi is charging 15 rupees. For the second kilometer, it would be 15 rupees for the first kilometer and 8 rupees extra for the second kilometer. So if a person is traveling 2 kilometers, he is going to pay 15 rupees for the first kilometer and 8 rupees for the second kilometer. So that would be 23. Now he is going to again pay 8 rupees extra for the third kilometer. So if you are traveling for 3 kilometers, you will be paying how much? 31, 8 rupees more. If you are traveling for 4 kilometers, you will be again paying 8 rupees extra, that is 39. Now please notice here we are starting from 15 and every time we are adding 8. We are adding 8 to the next term to get the next term. Here. So this is an arithmetic progression. Yes, this is an arithmetic progression because we have a common difference, that is positive 8. Now coming to the next one, the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So if you have a particular amount of air, you remove 1/4 from it, 1/4 of the air remaining in the cylinder at a time. So like for example, let's say that you have 100 rupees. I take 1/4 from you, 1/4 of the money from you. I'll be taking 25 rupees from you. So how much you'll be left with? You'll be left with 75, right? Now you have 75 rupees and I take 1/4 of the money from you. Here I had taken 1/4 of 100. Here I am taking in the next case 1/4 of 75. So it will be different from 1/4 of 100, right? So I took first 25 rupees from you as 1/4 of 100 and now I am taking 1/4 of 75, the remaining which you have. So let us solve this one. Let us see how much we are getting. We'll get something in decimal. So we'll get here 1 and this would be 8. 1 and then this would be 8 point, how much? This would be 8 point something, 18 point something we'll get. So here I am giving you, here I was taking 25 rupees from you and here I was taking 18 rupees from you. So 1/4 of the remaining every time I was taking from you. So I'm taking different numbers from you, different amount from you every time. So this is not an arithmetic progression because every time we are calculating 1/4 of a different quantity. So it will come out to be a different number. So it's not the same number throughout. So in this case, since we don't have the common difference, so it is not an arithmetic progression. Now coming to the next one, the cost of digging a well after every meter of digging, when it costs 150 rupees for the first meter and rises by 50 rupees for each subsequent meters. I'm repeating this. The cost of digging a well after every meter of digging, when it costs 150 rupees for the first meter and rises by 50 rupees for each subsequent meters. So 150 we are charging for the first meter. So we have to charge 50 rupees extra for the second meter. So that would be how much? 200. Then 50 rupees extra for the next one. It would be 250. 50 rupees extra for the next one, 300 and so on. So here as we can see, we started from 150. Now we have 200, 250, 300. So we are adding 50 here. We are adding 50 again here. Again we are adding 50. So we have a common difference. The common difference here is positive 50. So yes, it is an arithmetic progression. Now we have the amount of money in the account every year when 10,000 rupees is deposited at compound interest at 8% per annum. So here this is the case of compound interest. The amount of money in the account every year when 10,000 is deposited at compound interest at 10%, 8% per annum. So we have 10,000 rupees right in the beginning. At the end of the first year, when we'll be receiving 8% interest, we'll be getting how much? How much is 8% of 10,000? 8% of 10,000 would be how much? We're going to get here 100 rupees, 800 rupees. Now 10,000 was the money which we invested right in the beginning. 800 rupees we have the interest. So we'll get 10,800. Now the next year, the second year, we'll be getting 10,800. We'll be getting 8% of 10,800. So it will be a different amount from what we received here. So here we added 800 rupees to get the next one, 10,800. Now the next year we'll be receiving 8% of 10,800. So it will be a different amount. We can calculate this also. We'll get here 864 rupees. So here we added 800 rupees. Here we are adding 864 rupees. So we don't have the common difference. We are adding different numbers every time. So this is not the case of arithmetic progression. So when we talk about compound interest, it's not the case of arithmetic progression. But yes, in simple interest, it is the case of arithmetic progression, because we keep on calculating the interest on the same amount. And if the rate of interest remains the same, then in that case, we'll be adding fixed number every time. So for simple interest, it's an arithmetic progression, because we are calculating interest on the same amount, provided the rate of interest also remains the same. And for compound interest, in any case, it is not the case of arithmetic progression, because every time we are adding different amount as the interest. Now we have write first 4 terms of the AP when the first term A and the common difference D are given as follows. So we have A as 10. As I just told you earlier, A denotes the first term, D denotes the common difference. We have to write the first 4 terms of the AP. So first term is already given to us, 10. Every time we have to add 10 to the previous term to get the next one. So the next one would be 20. Next would be 30. Then we have 40, 50, like this. So these are the first 4 terms. These are the first 4 terms. Now we have A minus 2 and D 0. We have to again write the first 4 terms. The first term we already have minus 2. Add 0 to it, you will get minus 2. Add 0 again, you will get minus 2. Again, add 0, you will get minus 2. So when we keep on adding 0, it will not make any difference in the value. So we'll be repeating the same number. Now coming to this one, we have A as 4 and D minus 3. So we're going to start from 4. Add minus 3 to it. You're going to get how much? You will get minus 1. Now you add minus 3 to it. You will get how much? Add minus 3 to it. You will get minus. This would be how much? This is not 4. This is positive 1. Sorry. This is positive 1 because we started from 4. We are adding minus 3. 4 plus minus 3 is going to give us how much? Positive 1. Now to this one, when you add minus 3, you will get minus 2. To this minus 2, when you are going to add minus 3, you will get minus 5 here. So here we have 4 plus positive 1, minus 2, minus 5, like this. Now here we have the first term as minus 1 and the common difference we have as half. That's 1 by 2. For convenience, we can write this as 0.5 also. So minus 1, we are adding 0.5 to it, we will get minus 0.5. Now you add minus 0. You again add 0.5 to it. To this minus 0.5, you add positive, you add 0.5, you're going to get how much? 0. The next one again we are going to get by adding 0.5. So you can take half also, that's okay. But just for convenience, I've taken 0.5. So you can add 0.5 to this, you will get 0.5 here. So these are first 4 terms of the arithmetic progression. Now let us discuss this one. We have A as minus 1.25. That's the first term. We need to get the second term. So D, the common difference, is already given to us, minus 0.25. So first term plus the common difference will give us the second term. So this would be minus 1.5. Now to this minus 1.5, if we add minus 0.5, we will get minus 1.75. And to this minus 1.75, if we add 0.5, we are going to get minus 2. So these are first 4 terms of the arithmetic progression. Now in the next question, for the following APs, write the first term and the common difference. Now these are the APs which are given to us. We already know that these list of numbers, they are APs. APs means arithmetic progression. That's just the short form. We have to write down the first term and the common difference. So very simple. The first term, as we can see, is 3. Let's solve for the common difference. So for the common difference, you take any 2 consecutive terms, like you can take these 2 also. It's quite simple. From the second term, you subtract the first one. You're going to get minus 2. Please notice when the numbers are decreasing, then in that case, the common difference is negative. When the numbers are increasing, the common difference is positive. And when the numbers remains the same number, like I showed you right in the beginning, 5, 5, 5, 5, and so on. then in that case the common difference is 0. So here we have A first term as 3 and D the common difference is -2. It is -2. Now coming to the next one, we have -5, -1, 3, 7 and so on. Here the first term is -5 and the common differences, you can just take two numbers randomly. We can take these two. So from this one, we'll subtract 3. So 7 minus 3 will give us how much? 4. Every time we are adding 4. We are adding 4. Please notice the numbers here are increasing. So the common difference is a positive number. Now in this case, A is 1 by 3 and let us solve for D. So we can just take any two terms here. So from this 5 by 3, I'm subtracting 1 by 3. I'll get here 4 by 3. So the common difference is 4 by 3 and the first term is 1 by 3. Here we have the first term as 0.6 and the common difference, we can just take two of these. Let's take these two. We have 1.7 minus 0.6. So this is 1.1. So the common difference is 1.1 and the first term is 0.6. Now coming to the next question. This is the third question given on page number 99 of NCERT. Which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. So we have to first of all figure out whether it is an AP or not. If it is an AP, then we have to write down find the common difference, and we also have to write the next 3 terms. So in this case, please notice we are adding 2 here, we are adding 4 here. So we can just stop here. It's not an AP since there's no common difference. Here every time we are adding different number. So it's not an AP. Now coming to this one, we have 2, 5 by 2, 3, 7 by 2. So just for convenience, I'm writing this 5 by 2 as 2.5. I'm writing this 7 by 2 as 3.5. So we are adding 0.5 here. Here also we are adding 0.5. Here also we are adding 0.5. So yes, it is an AP. The common difference is positive 0.5. And coming to the next 3 terms, so up till 3.5 it's given to us. The next term we'll get by adding 0.5 to 3.5. We will get 4. The next would be 4.5. The next would be 5. That's all. So we just asked to write the next 3 terms that we've already written. Now let us observe this one. Minus 1.2, minus 3.2, minus 5.2, minus 7.2. So here we are adding how much? We are adding here minus 2. Because here minus 3.2 minus 1.2 will give us how much? Minus 3.2 plus 1.2, that is minus 2. So we are adding minus 2 here. Here also we are adding minus 2. Here also we are adding minus 2. So yes, this is an arithmetic progression where the common difference is minus 2. And now we are going to write the next 3 terms. We will get here after minus 7.2, we'll get minus 9.2, minus 11.2, minus 13.2. Now the next one, we have here we have minus 10, minus 6, minus 2, 2. So please observe minus 6 minus minus 10. So I am actually looking for the common difference here. Let us see whether we have common difference or not. Minus 6 minus minus 10. This will give you minus 6 plus 10. That is 4. You can solve for this also. Minus 2 minus minus 6. You will get minus 2 plus 6. That is 4. Now solve for the difference here. 2 minus minus 2. That is 2 plus 2. That is 4. Here there is common difference. D is 4 here. Positive 4. Every time we are adding 4 to get the next term. Yes, it is an arithmetic progression. And the next 3 terms would be after 2 we will have, if we add 4, we will get 6, then 10. The next one would be 14. Every time we are adding 4. Now let us discuss this one. We have 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2. So please observe here. If we take these two, 3 plus root 2 minus 3 will give us root 2. If we take this one and this one, we will get 3 plus 2 root 2 minus 3 plus root 2. We will get 3 plus 2 root 2, and we can take this minus inside. We will get minus 3 minus root 2. So these two will get cancelled. We will have 2 times of root 2 minus root 2. That will give us root 2. And even if you take these two, you will find the difference between these two as root 2. So every time the difference here is root 2, that means we are adding root 2 every time to get the next term. So yes, this is an arithmetic progression. This is an arithmetic progression with the common difference root 2. So the next term after this one would be 3 plus 4 root 2. To this 3 plus 3 root 2, we will add root 2. We will get 3 plus 4 root 2. Then we have 3 plus 5 root 2. And the next term is 3 plus 6 root 2. Now we have 0 0.2, 0 0.22, 0 0.222 and so on. Please notice it is not an arithmetic progression because every time we are adding different numbers. Like for example, if you take these two, 0 0.22 minus 0 0.2, what is the difference here? The difference here is you are going to get 0.02 here. The difference here is 0.02 and 0.22 if you take and then you subtract 0.2 from it, you're going to get 0.02. Now you take these two and find the difference. You will get 0.222, 0.22. If you solve for the difference, you will get here 0.002. So the difference is different. The difference is different. Here we have 0.02. Here we have 0.002. So we don't have any common difference. So it's not an arithmetic progression. Now coming to this one, we have 0, minus 4, minus 8, minus 12. Please notice it's very clear every time we are adding minus 4 to get the next term. You can also solve if you want to. Minus 4 minus 0 is minus 4. If you take these two, you will get minus 8 minus minus 4. That is minus 8 plus 4. That is minus 4. Minus 12 minus minus 8. That is going to give you minus 12 plus 8. That is minus 4. So yes, we have common difference. That is minus 4. It is an arithmetic progression. And the next three terms we have after minus 12 as minus 16, minus 20, minus 24. Now comes the next one. We have minus 1 by 2, minus 1 by 2, minus 1 by 2, minus 1 by 2. Clearly, this is an arithmetic progression since the common difference is 0. We have the same terms repeating. And the next three terms would be the same. The next three terms would be minus 1 by 2, minus 1 by 2, minus 1 by 2. Because because if we keep on adding 0 every time, it will not make any difference. Now we have 1, 3, 9, 27. So we are adding 2 here. We are adding how much? 6 here. And then we are adding 18. So it's not an arithmetic progression because we don't have the common difference. Here every time we are adding different numbers. Now let us discuss this one. We are starting from A. We are adding A here. Here also we are adding A. Here also we are adding A. Every time we are adding A to get the next number. So yes, this is an arithmetic progression where the common difference is A. And the next three terms after this would be 5A, 6A, 7A. So we have A, 2A, 3A, 4A. And after that, the next three terms would be 5A, 6A, 7A. Now coming to this one, A square, A cube, A raised 4. Please notice here we are not adding here a specific number. We are actually multiplying. We are multiplying in this case. So it's not an arithmetic progression because here we don't have the common difference. Please notice we are multiplying A here to get the next one. Again we are multiplying A to get the next one. Again we are multiplying A to get the next one. We are multiplying a specific number. We are not adding in this case. Now coming to this, the first one is root 2 here. The second one is how much? We can write this root 8 as root of 2 into 2 into 2. That is actually 2 root 2. Root 18 can be written as 3 into 3 into 2. That is actually 3 root 2. Square root of 32 can be written as 4 into 4 into 2. That is 4 root 2. So this is root 2. This is 2 root 2. Then this is 3 root 2 and this is 4 root 2. So please notice every time we are adding root 2 to get the next number. So yes, this is an arithmetic progression with the common difference root 2. So the next three terms would be 5 root 2, 6 root 2, 7 root 2. Now we have this one. 1 square, 3 square, 5 square, 7 square. So this is actually 1, this is 9, this is 25 and this one is 49. So clearly here we are adding 8, here we are adding 16, here we are adding 24. We are adding different numbers every time. So it is not an arithmetic progression. Now coming to this one, we have root 3, root 6, root 9, root 12. So root 3 cannot be simplified further. Let us simplify this. This is 3, this is 2 root 3 and this is root 6. So it's very clear we are not adding the same number every time. Isn't it? We are not adding the same number every time. So it is not an arithmetic progression since we don't have any common difference here. So it's not an arithmetic progression. Now the last one. We have 1 square, that is 1. This is 25. This is 49 and this is 73. So here we are adding 24. Here we are adding 24 and here we are adding again 24. So yes, it is an arithmetic progression where we have positive 24 as the common difference. Here the common difference is positive 24. So it is an arithmetic progression. Now coming to the next three numbers, 73, if we add 24 to it, we will get how much? 97. Now to this 97, if we add 24, we are going to get here how much? We'll get here 121. 121. To this 121, if we add 24, we will get how much? We'll get here 145. So these are the next three numbers. The next three numbers we have as 97, 121 and 145. Okay students, so I am winding up here. So in today's class we have learned the arithmetic progression. We know what is the common difference and we have learned how to identify the common difference, how to identify whether a particular list of numbers is arithmetic progression or not. And we've also learned how to solve for the terms of the sequence. Okay, so I'm winding up here. In the next class, we are going to discuss the general term of arithmetic progression. Thank you, students.